Welcome back to Math Mini Lessons. In this lesson, we're going to look at equivalent fractions and comparing fractions. As I work through my models, you're going to look for these three things. How I use strategy that proves two fractions are equivalent, how I create equivalent fractions using a sound mathematical strategy that will always work, and how I accurately compare two fractions with different denominators. Equivalent fractions are two fractions that are the same size, same amount, but they have different numerators and denominators. So for example, when I think about this half over here, it's really easy to think about halves because we break things in half all the time when we're sharing it with another person. Here are a whole bunch of fractions that are equal to 1/2, meaning they have the same amount. The same amount of the circles are shaded for all of these here. So 1 out of 2, 2 out of 4, 3 out of 6, 4 out of 8, and so on and so on and so on. So they have the same size, but different numerators and denominators. One way we can make equivalent fractions is by using a table. So for example, if I have 1/2, I can make more fractions with bigger denominators and bigger numerators by skip counting. So I'm going to count by, on the top part, ones, 1, 2, 3, 4, 5. And in my denominators, I'm going to count by 2s, 2, 4, 6, 8, and 10. And this is kind of like I'm taking the fractions, and each time I'm just breaking it into other pieces. So like 1/2, now I've broken my halves into 4 pieces. So here's my half. And now what if instead of 2 pieces, I broke it into 4 pieces? With 3/6, it's as if I took my original and now I've broken this into 3 pieces. So I have 3 here, 3 here. For 4ths, it's I take my original and I've broken it into 4 pieces. And on and on and on and on. So making a table like this, super helpful strategy for making equivalent fractions. Let's try making it another one. So let's say I have the fractions 2/3. And I want to make fractions that are equivalent to 2/3. I can use this same strategy. I'm going to count by 2s for my numerators, 2, 4, 6, 8. And I can count my denominators, 3, 6, 9, 12. And now I have, these are all equivalent fractions to 2/3. So there's something about this process, a pattern here, like a multiplication pattern for making equivalent fractions. Let's hit pause and jot this down into our notes. Let's look at our first model problem. Jamie has a small container that holds exactly 1/4 cup of dog food. How many times should Jamie fill the container and pour it into the dog's bowl to make exactly 1/2 cup of dog food? So we want to know how many 4ths are equal to 1/2. Actually, I kind of always like having the smaller denominator on the left. So how many 4ths make up a 1/2? So think about that. Her little cup. So she has like a little cup thing like this, but it only fits 1/4. And she's using that from the big bag of dog food. But she wants to get 1/2. So how many times does she have to go in there to scoop 1/4 to make 1/2? Okay, so we talked before about how to skip count by a number to get to make equivalent fractions. So I'm going to give you 2 ways you can do this. Here's one way. One way first is you can take the 1/2 and you can skip count until you get that 4 at the bottom. So on the top part, I was count 1, 2, 3, 4, and by my denominators 2, 4, 6, 8, and you can see it right here is this fraction. When I have 2/4, it's equal to 1/2. So that's one way, is to use our skip counting. Here's our second way. Because we're skip counting, and we know when we repeatedly skip count, we're just repeatedly adding or multiplying. So what you could do, and this is why I like having the smaller denominator on the left, is to do some thinking work. What number, how many times, how many 2's make 4? If you count by 2's, how many 2's make 4? Well, I know 2 times 2 makes 4. So if I know that's true, I can do the same thing to the top. So 2 times 1 makes 2. And this is another way of making an equivalent fraction. So we have our answer, how many fourths? 2 fourths, because that's what they were asking us here. All right, hit pause and jot this down. These are two very different strategies that you can use again and again to make equivalent fractions. And this one's awesome. These are awesome when you want a very specific numerator or denominator. Okay, let's get to our second model problem. And this was a state test question. We wanted to know which set contains only equal fractions, meaning they are all equal to each other. So we have to actually test this one out to make sure that it's true. So I'm going to start by, I like just separating things out, A, B, C, D. Let's do this. I'll start with A. And here's 1/3. And I'm going to try to do my skip counting to see if all of them would be true. Remember, they all have to be equal. So 3, 6, 9. Ooh, and I want 9 because definitely that's this number here. So I'm going to count by the top, the numerators, 1, 2, 3. Uh-oh. So this is the problem. Here I get 3 9's and here I have 2 9's. So these are not equal to each other. So I'm just going to stop right there because they all have to be equal. So A is out. Let's look at B, and I have 2 fourths. And I'm already seeing a problem because if I count by 4's, I'm not going to get 5 or 6. So, and this also doesn't make sense because look at all my numerators. All my numerators are the same, 2, 2, 2. So when I have equal fractions, the numerator and the denominator will be different. But this is, I already know this isn't going to work. So I'm going to try counting by 4's, 8, 12. See, I'm already skipping. I don't even get to 5 or 6. So this isn't going to work. So nope. Doesn't make sense, especially because my numerators are all the same. So I know that the pieces are different sizes, and so this isn't going to make any sense. Let's look at C, and I have 1/4 to start. All right, and the first one I'm going to look for is eighths. So 4, 8, 12. Awesome, because they're all multiples of 4. So I'm going to count by my numerators now. 1, 2, 3. So let's look what we got. The first one is 2 eighths. 2 eighths, so we're good so far. And now 12s, 3 12s, 3 12s. We're good. This is our correct answer. And just to make sure with D, let's see. I noticed the first part is I think the first part is gonna go well. But let's say, because I know 2, 4, 6, 1, 2, 3. So the first part actually goes really well. This works. But I'm not sure about the 16ths, but they're kind of far. So let's use our second strategy for that one. So here's 1/2. Let's prove 4/16. So how many 2's make 16? 8. So that means I need 8 to make it the same size up top. 8 times 1 is not 4. So nope, this one is incorrect as well. So there you have it. Look how I used my strategies, and I'm super flexible with strategies. Sometimes one strategy works really well for one problem and I have to maybe switch it up for the next one. So that's what happened with D. I actually tried 2 different strategies, and you can use both of them to create or confirm if fractions are equivalent. All right, hit pause and jot this one down into your notes. That's it for today. I'll see you in the next one, Math Marvels. Bye.